Desire is not enough to achieve your goal, but you should have burning desire. Hi everyone, my name is Sheikh Hussain. Welcome to my channel. This is the second video of this chapter, carbon and its compounds. In this video, we are going to discuss one of the most important concepts, versatile nature of carbon. What is the meaning of versatile nature? Versatile nature of carbon means it is a unique ability of carbon to form a huge number of stable compounds due to its tetravalency, catenation tendency, forming multiple bonds like a single bond, double bond and triple bonds, and showing isomerism, and also form bonds with the heteroatoms like sulfur, phosphorus and all. In the beginning of the science, carbon compounds were believed to have only in living organisms. The theory was called vital force theory. According to vital force theory, carbon compounds cannot be synthesized in laboratory, but they can be extracted only from living organisms. But Friedrich Wöhler synthesized an organic compound first time from an inorganic compound. That is, he has synthesized urea, which is an organic compound, from ammonium cyanate, which is an inorganic compound. From then, there was a huge development in organic chemistry or chemistry of carbon compounds. Okay, let's dive into our main topic. Here we know that carbon having atomic number 6 and its electronic configuration is 1s2, 2s2, 2p2. But in the excited state, its electronic configuration is 1s2, 2s1, 2px1, 2py1 and 2pz1. It is having 4 unpaired electrons in its valence shell. Due to these 4 unpaired electrons, carbon has got the valency 4. That means carbon can form 4 bonds at a time. It can combine with the 4 univalent atoms. Okay, to understand this better, we'll start with one of the most important properties of carbon, that is catenation. What is catenation? Catenation is such a unique property of an element in which the atoms of the same element link it together to form long chains or rings like compounds. For example, if you take diamond or graphite, which contains only carbon atoms, it has a huge number of carbon atoms linked together. There is no other atom exists in diamond, carbon or fullerenes. This property is called catenation. Self-linking of similar type of atoms to form chains or ring-like compounds. Here, the uniqueness of carbon is carbon has the highest catenation tendency due to its small size and high bond energy. You know one thing, carbon is the only element which shows the highest catenation tendency than any other element of the periodic table. The main reason behind this is due to the small size and highest bond energy of carbon molecules. Apart from carbon, few other elements also can show catenation tendency. For example, silicon, phosphorus, sulfur, but their catenation tendency is very limited. See, for example, here I have drawn the structure of sulfur molecule, that is S8 molecule, which is in crown shape, and it has 8 sulfur atoms. But in case of carbon, it forms chains and rings like compounds with millions and billions of carbon atoms. That's the speciality of carbon. Hydrogen forms single bond, oxygen forms double bond, nitrogen forms triple bond. Then what about carbon? Carbon can form single bond, carbon can form double bonds, carbon can form triple bonds. That is the speciality of carbon. That means the only atom which can form all type of bonds is a carbon atom. Based on the number of bonds between carbon atoms, the carbon compounds are mainly classified into 2 types. They are saturated hydrocarbons and unsaturated hydrocarbons. The carbon compounds in which there is a single bond between 2 carbon atoms are called saturated hydrocarbons. They are also called alkanes. Alkane. There are 2 parts in this word, alk and ane, alkane. Here ane represents single bond, alk represents number of carbon atoms. The general formula of alkanes is CnH2n plus 2. CnH2n plus 2. What does it mean? The meaning of this is, here n represents the number of carbon atoms. If number of carbon atoms are 2, hydrogens will be double plus 2. That means if I write the structure, if I write a molecule C2 here, the number of hydrogens will be 2 2s are here in the place of n you substitute 2, then 2 2s are 4 plus 2 6, C2H6. That's an alkane. That's an alkane. You can easily identify the given compound is whether alkane or not. just by counting the number of carbons and hydrogen atoms. For example, if I give one more molecule, you try it, C3 and H. If there are 3 carbon atoms, how many hydrogens should be there in that molecule? Since there are 3 carbon atoms, you double the number of carbon atoms, then it becomes 3 2s are 6 plus 2, double plus 2, then 6 plus 2, 8, then it is called an alkane. That means the number of hydrogen atoms will be double and plus 2 than the number of carbon atoms. Next come to the double bonded compounds. Double bonded compounds are called unsaturated hydrocarbons. Similarly, triple bonded compounds are also called unsaturated hydrocarbons. That means double and triple bonded carbon atoms collectively called as unsaturated hydrocarbons. Double bonded compounds are particularly called as alkenes. Alkenes. Here ene represent double bond, here ane represent single bond, here ine represents triple bond. Ane single bond, ene double bond, ine triple bond, and all are having this word alk in common. What is the meaning of alk? Alk is nothing but number of carbon atoms. Alk represents number of carbon atoms. It is also called root word. Root word. Okay, based on the number of carbon atoms, the name of the compound changes. See here, this is a very important part. So if you know the number of carbon atoms, you can give the name to any compound, whether it is alkane, alkene or alkyne. So for example, here you have to know this list of names, that is root names or root words. Suppose if any compound is having only one carbon atom, its root name is meth or root word is meth. If number of carbon atoms are 2, root word is eth. Number of carbon atoms 3, root word is prop. Carbon atoms 4, but. 5, pent. 6, hex. 7, hept or sept. 8, oct. 9, non. 10, dec. So here onward 7, 8, 9, 10, you can say sept, oct, non, dec, like just like September, October, November, December. It's not exactly like that, just I am telling you to just remember. For in 10th class, it is better to remember up to 5 is enough. First 3 are very important for you. Those who are studying 10th class, first 3 are very important. So if there is 1 carbon atom, meth, 2 carbon atoms, eth, 3 carbon atoms, prop. Right? And next here you come to the general formula of alkenes and alkynes. In alkenes, general formula is CnH2n. That means if the number of carbon atoms are n, hydrogens will be 2n, means exactly double to the number of carbon atoms. Say for example, if I write C2, then hydrogens will be double, H4, 2 2s are 4. Then it will be an alkene. If number of hydrogens are exactly double to the number of carbon atoms, that is an alkene. For example, if you take C3, then number of hydrogens will be double, 3 2s are 6, H6. If you find such molecular formula, then you can easily say that is an alkene. Next come to alkyne, triple bonded compound. Its general formula is CnH2n minus 2. That means number of hydrogens will be double minus 2. Double minus 2. So for example, C2, if there are 2 carbon atoms, hydrogens will be 2 2s are 4 minus 2. 4 minus 2, 2. This is an alkyne. This is an alkyne. Next C3. 3 2s are 6 minus 2, H4. This is an alkyne. Okay. In this way you can easily find whether the given compound is alkane, alkene or alkyne. Just to make you confident about this topic, I'll give few more examples and you try to follow and you try to give the names of the compounds. Here I am going to write few compounds: CH4, C2H6, C3H8, C4H10, and so on. I can continue this list. And here, what's the name of these compounds? Here, while giving the name to any compound, first of all, you have to count the number of carbon atoms. Based on the number of carbon atoms, you have to write the root word. See, all these compounds, here there is 1 carbon atom, so its root word is meth. 2 carbon atoms, its root word is eth. 3 carbon atoms, root word is prop. And 4 carbon atoms, its root word is but. So that's all. First part is over. Next one, whether it is alkane or alkene or alkyne. Let's count number of hydrogen atoms. Here number of carbon atoms 1 and hydrogens are 4. That means 1 into 2, 2 plus 2, 4. So hydrogens are double plus 2 to the number of carbon atoms. So it is an alkane. This is methane, CH4. This is the first and simplest organic compound. Methane is the simplest organic compound, and its structure will be like this, CH4. Here carbon forms 4 single bonds with 4 hydrogen atoms. So here you can see the tetravalency of carbon. Next, C2H6, 2 carbons each, and hydrogens are 2 2s are 4 plus 2, 6. That means double plus 2. It is also alkane. This is ethane. 2 carbon atoms are there. Since it is an alkane, there will be single bond between the 2 carbon atoms. We have to, since it is an alkane, there is a single bond. Next, carbon valence is 4, no? And it should have, each carbon should have 3 bonds, because already 1 bond is there between the 2 carbon atoms. Remaining 3 bonds I am representing here, 1, 2, 3. And here total 6 hydrogens are there. 3 hydrogens are at first carbon and remaining 3 hydrogens are at second carbon. So this is the molecular structure of C2H6 or ethane. Next, C3H8. So this is 3 2s are 6 plus 3 2s are 6 plus 2, 8. 8 hydrogens are there. So it is also an alkane, and C3H8, you write 3 carbon atoms. Since it is an alkane, there will be single bonds between the carbon atoms. Now each carbon atom should have tetravalency, means 4 bonds. The first one is having only 1 bond between first and second, so remaining 3 bonds I am representing here. The second one is having 2 bonds, so 2 more bonds I am representing here. The last one is having 1 bond only, so it should have remaining 3 bonds. So after representing this, you distribute the hydrogen atoms. Total 8 hydrogen atoms are there. 1, 2, 3, 4, 5, 6, 7, 8. Over. This is the structure of propane. And you can also write simply CH3, CH2, CH3. CH3, first CH3, last CH3, in between CH2. CH3, CH2, CH3. This is a propane. And the last one, C4H10, you can do in the same manner. Okay, you try yourself. Okay, I am giving this you for your homework. Otherwise, my video length will be more. Okay, you try it yourself. Next, you come to similarly, few more examples we will practice. This time, I'll give the formulas randomly. C2H4, C3H4, C5H10, and C6H14. Try to give the names of these compounds. You try yourself, pause the video, you try yourself. Right. Now what I said, whenever you want to give the names to any organic compound, first you have to count the number of carbon atoms. Here 2 carbon atoms, so it is root word is eth. 3 carbon atoms, prop. 5 carbon atoms, pent. 6 carbon atoms, hex. That's over. First part is over. Next, count the number of hydrogen atoms. Here 2 carbon atoms are there, hydrogens are 2 2s are 4. When the hydrogen atoms are exactly double, it is alkene. So it is ethene. Name of this compound is ethene, means it will have a double bond. So what will be its structure? C, 2 carbon atoms are there. Since it is an alkene, there will be double bond between the 2 carbon atoms. Okay, after double bond, 2 valency 2 is satisfied, and 2 more valency we have to represent. So this carbon will have, this carbon should have 2 bonds, and this carbon should have 2 bonds. So total how many hydrogens are there? 4 hydrogens. 1, 2, 3, 4. That's all. That is the structure of ethene. Next, C3H4. 3 carbon atoms. 3 2s are 6 minus 2. Double minus 2. So this is an alkyne. Propyne. Its name is propyne. What will be structure? C. And there will be one triple bond between 2 carbon atoms. Here actually 3 carbon atoms are there. You can put triple bond anywhere. So for example, applying triple bond between these 2 carbon atoms. And here you just simply put one single bond. Now try to balance the valency of each carbon. So this carbon is having only one bond, so remaining 3 hydrogen atoms we have to mention here. This carbon is having 1, 2, 3, 4. So all valency 4 is balanced. And this carbon is having 3 bonds, so valency 1 is left, so H. This is the structure of propyne. This can also be written as CH3 single bond, C triple bond, CH. This is the structure of propyne. And you try to find the names and structures of these two compounds, C5H10 and C6H14. This is for your homework. Try it. If you cannot get it, and tell me in the form of comments, I will do it for you, right? Next, come to, this is about the alkanes, alkenes and alkynes. Here, carbon not only gives this type of simple compounds, carbon can also form cyclic compounds. It can also form certain cyclic compounds. Just 1 or 2 examples we'll discuss. And this is one cyclic compound. For cyclic compounds, we have to use the word cyclo. And total number of carbon atoms 1, 2, 3, 4, 5, 6. Hex. And all are single bonds. Hexane. Name of this compound is cyclohexane. Cyclic compound, 6 carbon atoms and all are single bonds. En, cyclic hexane. Here each carbon atom is having 2 bonds, 1, 2. So CH2. Here one carbon, if you take 2 bonds are there, remaining 2 bonds can be satisfied with 2 hydrogen atoms. CH2, 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 CH2. This is the structure of cyclohexane. Similarly, you can get one more compound here. This is also cyclic compound, cyclo. 6 carbons are there, hex, 1, 2, 3, 4, 5, 6 carbons, hex, and one double bond is there. So it is ene. This is cyclohexene. To satisfy the tetravalency, you see here, this is one carbon, 2 bonds are there, remaining 2 hydrogen atoms. This is a carbon, 2 bonds, remaining 2 hydrogen atoms. Here 2 bonds, remaining 2 hydrogen atoms. Here 2 bonds, CH2. And this carbon is having 1, 2, 3 bonds. So only one hydrogen can be placed. 1, 2, 3 and one hydrogen 4. And this carbon is also having 3 bonds. 1, 2, 3. So this will have one hydrogen. This is the structure and molecular formula of this compound, cyclohexene. Okay, right. Next, let's move on to the next topic, structural isomers. This isomerism is a very important concept, but you will learn in detail about isomerism in higher classes. Here just I will give you a 2 examples, whatever given in your textbook. CH3, CH2, CH2, CH3. Here, what is the name of this compound? 1, 2, 3, 4. 4 carbons are there, so bute. And number of hydrogen atoms? 3 plus 2, 5 plus 2, 7 plus 2, 10. So bute, 4 carbon atoms are there, bute, and the hydrogens are 10. 4 2s are 8 plus 2, 10. C4H10. If it is C4H10, what will be the name of the compound? Ene or ine? 4 2s are 10 plus 2. 4 2s are 8 plus 2, 10, H10. So it is an alkane. This is a butane. CH3, CH2, CH2, CH3. Now I'll make a small change here. CH3, CH, CH3, CH3. How many carbons are there? 1, 2, 3, 4. 4 carbons. Hydrogens 3, 3, 3 and 1. Total 10 hydrogens. Same C4H10. And this compound is also having same molecular formula. Both the compounds having same molecular formula. But what is the difference? This is a straight chain compound and that compound is having some branch. Okay, that is not a straight chain, that is having some branch. So such type of compounds are called isomers, and also they are called structural isomers. That means the compounds having same molecular formula but different structures are called structural isomers. Okay, name of this compound is 2-methyl propane. No need to worry about this name, that's its name, that's all. Till now we have discussed all the compounds in which carbon has combined with hydrogen. Carbon not only combines with hydrogen but also some other atoms. They are called heteroatoms like sulfur, phosphorus, oxygen, halogens, etc. Suppose if carbon combines with heteroatoms like halogens, oxygen, sulfur, etc., then we will get certain compounds with certain functional groups. See here, if heteroatom is chlorine or bromine, these are called halogens, 17 group elements, fluorine, chlorine, bromine, iodine. If carbon combines with halogens, we will get a compounds called haloalkanes. Haloalkanes. For example, if I write here CH4 is called methane. It is an alkane. Suppose here one hydrogen is replaced by chlorine, then it becomes a CH3Cl. This is called chloromethane. Alkane becomes a haloalkane. These are called haloalkanes. When hydrogen is replaced by any halogen atom, such type of compounds are called haloalkanes. Next, when hydrogen is replaced by oxygen atoms, and then we get different types of compounds, mainly alcohols, aldehydes, ketones and carboxylic acids. Generally these alcohols have OH as a functional group, and similarly any compound is having CHO or C double bond OH, they are called aldehydes. The compounds containing C double bond O or CO, they are called ketones. The compounds having COOH are called carboxylic acids. I'll write here. See, this is a bit important point. If any compound is having OH as a functional group, they are called alcohols, and CHO, this can also be written as C double bond OH. This representation gives you clarity about the valency of carbon. Carbon valency for 1, 2, 3, 4, double bond with oxygen, and this is called aldehyde group. And if there is a CO group, or this can be written as C double bond O group, and such compounds are called ketones. And if there is a COOH group, this is called carboxylic acid, and this can be written as C double bond OH. So these are the four groups we discussed there. And now how their names changes. This is very important part because most of the students get confused while giving the names to different functional groups. I will make this concept very simple to make you understand. See here, you just remember alkane, but in alkane, ANE, that E have not written because the next functional group name is starting with O, A, O. That means if the functional group, next functional group name is if starts with AEIOU, that is English vowels, then we should not write ANE, that E we should not write. Okay, if you are comfortable with this explanation, okay. Otherwise you simply remember alcohols are called as alkanols. At the end OL will come. Aldehydes will get all at the end. Aldehydes, all. First two letters of the name, aldehyde. Alcohols, last two letters of the name. Ketones, last three letters of the name. Carboxylic acid, it is unique. Oic acid will get, oic acid. That means if you find alcohol OH group, its name will be alkanol. Aldehydes, alkanal. Ketones, alkanone. Carboxylic acids, alkanoic acid. That's all. Alkanol, alkanal, alkanone and alkanoic acid. One or two compounds I will give and you try to give their names. So giving or knowing the names of organic compounds is very important here. CH3, CH2, OH. What is the name of this compound? So it is OH is there, no? That means it is a alkanol. It is alkanol, we know. You just substitute name of the root word, alk. So how many carbons are there here? 2. If 2 carbons are there, then we'll write eth and the remaining part as it is. Enol, alkanol, ethanol. So the name of the compound is ethanol. So if I write CH3, CH2, CH2, OH. What is the name of this compound? So OH is there. So it is also alcohol, and root word is 1, 2, 3 carbons. So propanol, propanol, alkanol. In the place of alk, what we have written? Propanol. That's all. And you can practice many such examples. And next one, aldehyde. What is the name of this compound? HCHO. HCHO. How many its name is alkane aldehyde. CHO is there, aldehyde, alkanal. So how many carbons are there? 1. So in the place of alk, I'll write meth. Methane methanol. Its name is methanol. If I write CH3 CHO. CHO is there, so it is aldehyde group. So its name is alkanal. 2 carbons are there, so ethanol. Such simple. If you know the basics, and it is very easy to understand the science. Next, ketones. I'll give only one example for ketone. CH3COCH3. Here in between CO is there. Such compounds are called ketone groups, and for ketones the general structure is alkane one. So in the place of alk, you put number of carbon atoms, 1, 2, 3 carbon atoms are there. So propane one, propanone. Okay, one more example also I'll give. CH3 CO CH2 CH3. Here CO group is there. CO group is nothing but ketonic group. So alkanone. How many carbons are there? 4 carbons. So butanone. That's all. Next, final and last one, carboxylic acids. HCOOH. If COOH is there, that is carboxylic acid. Name of the carboxylic acid is alkanoic acid. So in the place of alk, what we should write? 1 carbon is there, so meth. Remaining part as it is, enoic acid, methanoic acid. If I write CH3COOH, then number of carbon atoms 2, so we should write ethanoic acid. That's simple. If you know the basic structure of the nomenclature, alkanol, alkanal, alkanone, alkanoic acid, you can write the name of any functional group just by substituting a root word alk in the place of alk. You will get the remaining name very simply, very easily. That's all. And the last topic is homologous series. What is homologous series? Homologous series is a very simple concept, but important for board exams. It's very simple. Let me take a series of some compounds like alkanes, CH4, C2H6, C3H8, C4H10. These are all the alkanes from with 1 carbon, 2 carbons, 3, 4 and so on. You take any 2 compounds of these and see, for example, second and third I will take. The second compound is having 2 carbons, third one is having 3 carbons. The number of carbon atom, difference in the number of carbon atoms 1 carbon, and difference in the number of hydrogens 8 minus 6, that is 2, CH2. That means the difference in the number of carbons and hydrogens between these 2 adjacent compounds is CH2. Similarly, if you take third and fourth compounds, here 4 carbons, here 3 carbons, so 1 carbon is the difference. Here 10 hydrogens, 8 hydrogens, so 2 hydrogens, so CH2. And first and second, 1 carbon, 2 carbons, and here 1 carbon, so 1 carbon. Hydrogen 6 and 4, 2 hydrogens. That means difference between 2 adjacent compounds is CH2. Such compounds are called homologous series. So you can write for homologous series, you can write any example: alkanes, alkenes, alkynes, alcohols, aldehydes, ketones. You take any example that form a homologous series. So my dear students, I hope you understood this topic, and this is one of the important topics. If you like my videos, please subscribe and share with your friends. Be healthy and be happy. We will meet in the next video. Thank you for watching.